I don't know what y'all think, but I think that's pretty.
Hey everyone, we are back again doing Advent of Code Day 3. Advent of Code is a thing that is released every year. 25 programming challenges, just like one of those old Advent calendars where you'd break out and get a little toy or a piece of chocolate or something. A little nugget for your brain. Usually I do these every year. I start off and then I get distracted or busy, so I stop. So I'm doing them on stream so that maybe people will enjoy it and maybe it'll keep me motivated to do it throughout. So that's the plan. We're on day 3, so we're doing okay so far. So let's get into it. As you see, we have 4 stars, so we're perfect so far. I haven't been really doing it for time because I'm not waking up early just to do these problems. That's silly. That's madness. We're not doing that. Forget that. I just want like a little bit of desktop audio going on here. Very hard to tell. Motion VR. Thank you. I will go. I will go. So let's get into this problem. The toboggan login problem's resolved. You set off towards the airport. While travel by a toboggan might be easy, it's certainly not safe. There's very minimal steering, and the area is covered in trees. You'll need to see which angles will take you near the fewest trees. Makes sense. Ooh, this might actually be the first one that's actually a little challenging. That's fun. Okay. Okay, I'm glad I start now and not like a little later. I was originally going to start a little later. Due to the local geology, trees in this area only grow on exact integer coordinates in a grid. How very convenient. You make a map, your puzzle input, of the open squares and trees you can see. So the open is a period and trees are little hash symbols. For example, we got this guy right here. Oh, oh. These aren't the only trees, though, due to something you've read once involving Aboriginal genetics. Arboreal. I don't know what that actually means. Let's look that up. Arboreal. Arboreal. Oh, living in trees. Okay, so we're learning lots of stuff here. Arboreal. These aren't the only trees, though, due to something you read once about involving arboreal genetics and biome stability. The same pattern repeats to the right many times. Okay, so we have like a little slice here, but it repeats infinitely, or maybe not infinitely. You start on the open square on the top left corner, and need to reach the bottom, below the bottommost row of the map. Okay. The toboggan can only follow a few specific slopes. You've opted for a cheaper model that prefers rational numbers. Start by counting all the trees you will encounter for the slope right 3, down 1. Huh. What does that mean exactly? Well, actually turn off the music so I can focus in a little bit here. The toboggan can only follow a few specific slopes. Start by counting all the trees you will encounter for the slope right 3, down 1. From your starting position at the top left, check the position. Arboreal related to trees, not just living in trees. Oh, right. Okay, that makes sense. From your starting position at the top left, check the position that is right 3, down 1, then check the position that is right 3, down 1 from there, and so on until you go past the bottom of the map. Oh, okay, so the toboggan can only go on follow a few specific slopes, so it... Hey, Baka, how's it going, man? Did you change your Twitch name? I remember you having a Twitch account, but I don't remember it being Motion VR. I guess that fits with all the VR stuff that you do, though. From your starting position? Okay, so we have a cheap toboggan, apparently. So it's super awesome. Awesome. Great name change. Love it. We have a cheap toboggan, so it can only go down very specific slopes. Okay. I think that we're down for this. Okay, so from your starting position at the top left, check the position that is right 3, down 1. So that would be like this guy right here, right? Then check the position that is right 3, down 1 from there, and so on until you go past the bottom of the map. The locations you check in the above example are marked here with 0, or I guess that's an O. I'm not sure if that's an... I think that's an O, where there was... by all means, Baka, be in and out. I'm just here talking to myself. That's all that I'm here for. The locations you'd check in the above example were marked here with O, where there was an open square, and X, where there was a tree. Okay. Right, so if we go down 1 and over 3... maybe I miscounted. If it's going down and over 1, shouldn't it be like this dot right here, not the hash symbol? 1, 2, 3, 4, 5, 6. Yeah, because that'd be 6, right? Oh, but it's over first, and then okay. So it's actually, this is on mark 4. 1, 2, 3. Oh, okay. So we hit a tree that way. From your starting position from the top left, check the... Okay. The locations you check in the above example are marked here with O, where there's an open square, and X, where there's a tree. Okay. This all makes sense now. In this example, traversing the map using the slope would cause you to encounter 7 trees. Starting in the top left corner of your map and following the slope of the right, right 3 and down 1, how many trees would you encounter? Okay, so this all makes sense. This is actually really easy. We're going to have an input. And we're not really trying to dodge the trees in this version. I wonder if the next version we're going to try to dodge the trees. But we're basically plummeting through and we're seeing how many trees we hit as we go down. So we'll take the input. We'll make this whole thing. I wonder if the arrows are going to be there. I don't actually know. Let's take a look at our puzzle input real quick. And okay, no arrows. Okay, the arrows are cringe. So we're okay with that not being a thing. So we'll basically take these as like an array of lines, just like how we did here. It's actually kind of like a simpler version of not this one, but our problem from yesterday, where we'll reuse this guy here to get all the input lines, and then we'll just treat them as kind of like an array and keep track of the index we're on. And when we reach the end, we have to loop over. So there's two different ways we can do that. We can actually do some math to make sure that we are like at the right index. Alternatively, we can calculate how far right this needs to go, and just kind of like duplicate each of these strings. So Ruby has a really nice mechanic to automatically duplicate strings next to each other. So I can actually demonstrate that right now. Hello. Oh wait, that's not it. Is it actually just normal multiply? Yeah. So we can actually use that to really trivially do that. And actually, since we don't really care about this, we could actually just duplicate it as like a really big number and just be done with it. That's kind of like wasteful. It's probably like the most like foolproof thing though. Okay, so we know it's gonna be down one, right 3. So first off, let me move this off, and we're gonna save this. Place the old file on our desktop, and we will move it today. Not today, but to the day. Okay, perfect. So we have a 323 we have 323 lines worth of trees here, right? And I don't have a ruler on here. Oh wait, I'm using Vim key binding, so this should work. Vim turn on. This is not what I'm looking for at all. How to show the that ruler. I guess maybe this version of VS Code's key bindings does not support that. Maybe. Oh wait. I'm actually so dumb. We have it right over here. So 31 characters. Okay, this. Or I guess 30 characters because it's one base, right? We're back with the one based stuff. Oh my god, no. I wonder if like this actually makes some sort of ASCII art or something like that. So if we have something that's like a 30 wide, let's actually just do some quick math and see like how much we actually need here, right? Three characters wise. How many lines did I say this was? I don't even remember. I said this was 323. 323 lines tall. So like the 30 actually doesn't matter. If we go down, this is always just going to be like 3 times, right? Because every line we move over. Ooh. Let's do this. Okay. 323 times 3. Because every time we go down, every one line is going to be, it's actually like, oh, 969, nice, okay. Every time we go down, it's going to be one more of these, right? Every time we go down, we're going to move over 3 more, yeah. I feel like I'm babbling right now, that's fine though. So if we divide this by 30, this will tell us how many times we have to multiply our character, our base string by. So if we multiply each string and have it duplicate 33 times, that's going to make sure that we never overflow. And we just kind of like get that for free and we don't need to think hard. Again, if I was doing this like in real software, I'd be like, nope, we're not doing that. That sounds incredibly wasteful. But for this, who cares? It's it's a coding thing. Most people are spending like 3 minutes on it. I've already went way over the allocated time that anyone actually really wants to spend on this, right? We're gonna just copy pasta our problem 1 because, as I mentioned, we're basically just stealing input lines. That's the only thing we care about. We're keeping our same setup. We have our main, just so that we can write methods all over the place, and we don't need to worry about like the order that we define things in. It doesn't matter. So what is staying the same and what's different? Okay, so lines equals input lines, and what we're going to do is we're going to multiply this by 33. Line times 33. So that's going to be thick enough for us, right? Yeah, Baka, that's kind of like the whole idea. I love your explaining as you go. Let us see the thought process. Yeah, that's kind of the ideal. If I was just like kind of like sitting there and blindly typing, that wouldn't be too fun for anyone, right? Okay, so we have our really thick lines right now, so we can actually just print that out initially and see what that looks like. Making me realize how similar Ruby is to C and Python. Yeah, they're all kind of like AGL-based languages. Ruby is probably more like Python than C because C, one, isn't object-oriented. I am not really doing much OOP here, but C obviously isn't OOP at all, and I'm just kind of doing it this way because it's kind of like a scripty idea here. These are all kind of like disposable throwaway programs. If I was writing something bigger, like a yeah, so like Ruby and Python are kind of like in the same family. They have like different syntaxes slightly, and their libraries are slightly different. But honestly, like any problem that you can do with Ruby, you can probably do with Python and vice versa. It's just a question of like, I think that Ruby is a slightly like cleaner design in a pure OOP sort of sense. Just how, because literally everything in Ruby is an object, while in Python, there are some things that are kind of like magical and not objects, I believe. I haven't done that much Python, so I could be completely lying about that. But I think like maybe like integers and stuff, like you can't like add methods on while you can in Ruby. But Python's really dope because it has a really efficient runtime compared to Ruby. It has and also because it has like more like library integrations. So if you're doing things that integrate with other things, usually Python is like a really good choice for that. Oh. Puts lines inspect. So let's just run our, where are we? Let's go to day 03. Let's go Ruby problem 01. Okay, so we have some really thick lines. Let's actually just as a sanity check, let's find out what the size of each of these are. Okay, so these are all 1,023 characters each. So that's what we're going for. So because like what 1023 divided by 3, what does that look like? 341. So that should definitely be that this could handle like around like 340 lines worth of input. So we're actually good here. We could actually be like clever if we wanted to and determine the 33. We kind of did that manually, but we could do that we could count like the size of the input lines and do math in the program to automatically come up with the 33 number. I imagine that they're going to be tweaking the problem next time for the part 2 of this, so maybe that will come in handy there. We already did the math here, so it doesn't really matter. We're just going to be lazy. Let's actually put a little comment about that. File is 323 lines tall, and we're perfect. Oh, I always forget. Oh, I always screw up Vim key bindings. I've been doing Vim key bindings since I was probably I probably first picked it up in freshman year of college, and I still like only know the basic input. It's actually quite funny. What does having a better runtime mean? Um, Ruby MRI, like there's a few different runtimes for Ruby. So like in C you compile into an executable, while in Ruby you and in Python it's an interpreted language. It has like a compile step, but like basically like you run like Ruby and then file name, or you run Python and file name to make a running thing. The Python executable is generally considered to be more performant than the Ruby executable. You can also, in both cases, also do like Java Ruby and also Java Python to use a different runtime. I'm not sure if you do that route, which is better. But then there's like weird things like you can't like link in C libraries, but you can link in JVM libraries, which is kind of cool, but a bit different as well. There was okay. So we have proof of concept. We have proof of concept that 341 is a reasonable size of these. So let's go back to the problem. And so what we're doing is we're scanning each of these strings, and we're kind of like keeping a log of like where we are. Yeah, anytime, Baka. I'm happy to talk about weird programming miscellanea any time of the week. So because the slope is like 1/3, actually would that be like 1/3 rise over run, right? Negative 1/3 slope. Okay. So we're basically going to be iterating over each line and incrementing like our character index each time. That sounds pretty reasonable to me. So let's start off with a counter. Chart position. We're gonna pretend that we're 0 based here. And the 1 doesn't really matter. We're just gonna be like increasing by 3 each time. So this is actually really, really easy. Lines. Each. Do I want to do each, or do I want to transform this into a different array? I think let's initially what we're going to do is we're going to just turn this into like the character we're inspecting and see if like that looks right. We can compare it against the input and make sure that we're doing this in kind of like a sane way. So we're going over each line. Just like last time, we're going to split on empty string. Zero-based, are we counting like machines or something? Yeah, we're counting like machines because we can actually use array syntax on once we split this. Actually, can I just like use array syntax on a string without, because we had to do that before because we were iterating. Foo1. Okay. Yeah, we are the machine, Baka. Don't let anyone tell you otherwise. So we actually don't need this split nonsense. That's just silliness right there. So let's just actually map to char position. We're going to start off at position 0. And we're going to increment this by 3 each time because we're doing that every line, and because we want to end up with the char, we're just including this at the end. I don't know if like actually tap exists here. There's a cool little thing in Ruby where you get to do. Let's just test that out. Tap. Okay, so that works. So tap lets you. The result of tap will always be the thing that's called on it, right? So I could have anything inside this block, and it will always return back foo. And it's nice to have little like side effect things, but you don't want to like store it in a variable again. So in this case, I can actually do tap. So we're going to be incrementing the character position, but we actually want to return line position from this block, and so that'll be like the last thing that's evaluated in the map. And so that's going to do like what we want it to do. So we don't need this puts down here. That's kind of like a meaningless thing right now. So we're just going to put the result of this, throw on inspect, and this should give us an array of one character each time, and we shouldn't have any like index issues or anything like that. It should work pretty well for us. So let's exit out of our console here, back out. Problem 01, that's still where we're at. This is the same issue we had yesterday because map doesn't actually run any of these until it's forced to. So this is just returning an enumerator, which is kind of like an abstract collection type. So we can just do 2a. That's going to turn it into an array, so it actually like actualizes, and we have something that can be inspected here. Am I doing something? Am I like mad here? What's going on here? That's not right. Why is that? That should be returning. Let's just be a little. It might be like something where like it's not binding quite right here. Like the order of operations might be screwing me up here. Okay, so let's just say instead we do. That's our chars. Let's chars inspect. Okay, that's what we were looking for here. So we have a the important thing is we never ran into like an exception. Exceptions are very lame. We hate exceptions because if we went over our limit, that's what would have happened there. If we ever like exceeded like the length of the string, because this is automatically duplicating to the right. So we know we duplicated it enough times. That's really what I was testing there. So the rest of this problem is actually really, really dead simple. From your starting position, check the position, check the. Okay, so we're counting all the trees I encounter, and the trees are the hashes. So we can just introduce another counter here. Tree count. And I think the tap might actually be making things look kind of like a little Wonkadoo. And also, we don't need to map. We're just going to iterate over this. Map will evaluate each thing and return the value of the block. While each is just like a loop. It throws away the value. It's not actually important here. So we're going to do char equals blah, blah. We're going to store that there. We're going to increment the position each time. And if char equals hashtag tree count plus equals 1, we can make this a little prettier with a postfix thing there. 2a is never going to do anything useful because this is just going to return nil now, or It's gonna return nil or just like the original lines. I'm not sure. I don't remember. It's not important. You never actually do anything with the return value of each. So let's actually just print out the tree count. And hopefully, like hopefully this is just like a good number, and we'll plug in the number and win. Okay, so according to our program, we hit 173 trees. That's very awkward. It's very cringe. We're not into that, but I think that's the answer. So what's going to happen now is we're either going to be victorious or we're going to have the timeout of shame. We are right. We have a gold star. We're back in middle school, in elementary school. We're getting our gold stars. We're feeling good about it. Okay, so now there's part 2. In this example, traversing the map using the slope would cause you to encounter 7 trees. Starting, okay, so this was from before. So now we're on new stuff. Time to check out the rest of the slopes. We can actually get rid of this here because that's kind of distracting. Time to check the rest of the slopes. You need to minimize the probability of sudden arboreal stop, after all. Determine the number of trees you would counter if, for each of the following slopes, you start at the top left corner and traverse all the way down. Okay, so we're doing the same thing, but we're having a bunch of different slopes. This is kind of weird, kind of fun, kind of interesting. We already okay, so oh, this is really interesting. So we actually have one that's down 2. That's very different from what we did before. So I think what we need to do is we need to generalize this guy. So we'll start off. We'll just make a copy of this. Ugh. Can I actually type? Can I actually type? Do I have focus of the window? Problem 2. Okay, this is probably like the first actually interesting problem that we've encountered throughout the entire advent of code so far. Everything else has been very trivial. This is not necessarily hard, but like it's actually like we have to think a little bit here. So we're gonna want to take this logic, but we have some hard-coded concepts. We have the line size of 33. That's a little cringe. And we know that the answer that we're looking for is 173. So if we iterate this and change it, because we just kind of like need to take this stuff and make it general and work for arbitrary slopes. This is all very everything is like really straightforward except for the down 2. That's one that's a little different. It's a little weird. What I'm thinking about right now is we kind of like did like the lazy route of just multiplying the string over and over again. That might not be good, possibly. That might not be good for the general case. Let's first just see like what it looks like to do this in the general case. So we do have our fixed things. Our character string are 300 wide. It's fixed that it's this many tall. So, and the way we did this before was we took lines tall times, how do we do this? We did times the slope, right? Times the horizontal slope. And then we took that all. We divided it by the length of let's actually use some better words here. Line count. Line sol is not a real thing. Let's not be silly here. Line count times horizontal slope divided by line length, and we just kind of like did a +1. It's technically like a ceiling, but we're kind of like assuming integer math here, right? So that's our algorithm. So how does this algorithm change? How does this algorithm change if we're going down 2 lines sometimes? This is that part's very weird for me. I think we can encompass this initially, so this is kind of like an easy case. We can write this to kind of like calculate the 33. Line multiplier. What do we need to pass in here? I think we pass in the lines. We're assuming, if we assume that all the lines are the same length, we can infer the length from that. I think that's fine. I think that's all we need, right? Line size plus, actually multiplied by, oh, we also need the slope. We also need the slope. It's actually kind of like the inverse slope, right? Because we're talking about, when we talk about, slope is always rise over run, right? So slope, we're really talking about, it's technically -1, but like if we were kind of like change our orientation, it's really 1 and 3, right? Because the run is 3. So inverse slope is just would be 3 over 1. And so we've just been able to multiply by 3 because we're kind of ignoring the denominator there. Okay. Let me just actually just check something really out. Let me check something really out. When 1 divided by 3, that's obviously going to be 0. I'm trying to see like what I need to do to make this floating and sealing, because I think I actually want floating point math here. Seal? Seal? Okay. That's what we're looking for. I actually don't use that sort of math function all that often in my day-to-day work. So that was a little bit of a thing for me. Okay. So let's actually, instead of calling this slope, we'll call this inverse slope. And so what we're going to pass in is like 3, 1 by default, but inverse slope is run over rise as float. The float's very important because otherwise it's just going to truncate, and that's going to make us sad. That's only really going to matter when we get to the last case of right 1 down 1, right 1 down 2, because that's the only time that it's going to be a fraction. But I think we can solve for this case, and that's fine. And this needs to come in as a float. Yeah. So we're assuming this is a float. And we're dividing by, right. And we're also going to divide by lines. We can actually make this a little easier to read. Line length, lines. We're assuming that there's at least 1 line, right? I think that's a reasonable ask here. And we're actually going to make this a float as well, just to be paranoid. because we definitely want this whole equation to be done with floating point math, or else it's just going to truncate, and it's not going to do anything. It's not going to do what we want. Some things will just turn to 0 in certain points, because we'll be dealing with fractions that are less than 1, I think. Actually, probably not, but it's still gonna, it'll be off by 1 at the very least. So this should, if we plug in line multiplier here, where we had 33 before, we'll make this into multiple lines so that we don't go over our line maximum there. Oh, we don't need to do this on every... We don't need to do this on every line. This is not like a... It's not a great variable name, but I feel like we're kind of like running out of names here. Line multiplier. And I want to memoize this. I'm kind of like just going crazy. Like I feel like I'm like storing so many variables that I don't actually need, and I kind of like just want this to be a little more dry. So we can memoize this, which means that it's only going to run exactly once, and it'll kind of like store the value, and anytime you call it again, it's not going to rerun, it's just going to return the cached value. So I like doing this with a prefixing with an underscore, just to kind of like make it easier. You very rarely start variables with underscores, so it makes it very clear, hey, this is the method that we're using here. We're going to put this all in a block. So the way this works is the begin end just kind of like makes this as kind of like makes it look like one expression for the or equals. So the first time this runs, input lines is going to be nil. So it will not evaluate to true. So this is kind of just your basic short circuiting, right? This will be nil, so that means that we will evaluate the block file. It's going to do this IO here. And then at the end, the return value of the block will be assigned to this variable. So this I think my headset just turned off there because I don't have any music running. That's really funny. So hopefully I wasn't muted for too long. So input line. So this is just memoizing so that if I call input lines multiple times, it's still going to just work. So my motivation for that is the reason why I did all of that was so that I could say, I want to call it line multiplier, but that's already the name of my method. I can't do that. I can't do that. We're just going to call it multiplier. We can actually, I was about to say we can call it 3-1 multiplier, but you can't start a variable with a number. That's not actually a legal statement at that point. We can just run that. Input lines. And the inverse slope, so. So that's our rise and run. So we don't strictly need the divide by 1, but I'm just going to do it for consistency, because later on we're going to need that. And then we're doing this multiplier right here. So the reason I just went through this is because we need to make our multiplier more general purpose, and we already know what the correct answer is for 3-1 with our input file. So this should output the same exact thing. We should have 173 if we did this correctly. $173. So we are doing the right thing. We're making the right moves. Okay, so determine the number of trees you would counter for each of the following if you start from top left and traverse map all the way to the bottom. In the above example, the slopes are blah, 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 blah. Multiplied together. So what we're going to do is we're going to turn this main, essentially, into a method that is going to take a slope. And everything else will work out. The 1-1, the 3-1, the 5-1, the 7-1 are all going to work out of the box. I'm willing to bet. If we just pass in a different variable for it. However, the 1-2 is going to be the kicker. It's what's going to make us sad here. I'm thinking through right now. I'm just being quiet for a minute to think through. What does 1-2 look like? Because I don't really want to special case that. That seems kind of lame and cringe. We don't want to be lame or cringe. We want to be pog. So I'm thinking in a few tricky ways. One option is that we get tricky, and we actually have the concept of a float, right? We have the concept of, of a slope. So what we could do is for our counter, our character position, we could add it by the actual slope, not the we can add it by the actual by the inverse slope for every iteration. But we only do it if it's an integer, right? So like for example, in 1-2, every line we're essentially increasing by 0.5. So when it's on a 0.5, it's not a real space, so we don't do anything. We don't do anything then. And we would only do it when it's actually like an integer. When it's a whole number. I wonder if there's actually a test for that, for whether or not something is an integer. Is that like a... Okay. Oh, you don't like that either. Huh. I'm not sure, actually. Is there some sort of like math thing? Because I don't... You can't mod it. That's not like actually... Oh, that's... Huh. That's interesting. So can I can mod 1, 0.5. I can test if it equals exactly 0.0 if I mod to test if it's an integer. I feel like there has to be a better way to do this. Let me just check the Stack Overflow real quick, and by that I mean Google, because they're basically the same thing. Test if float is integer. It actually is recommending the mod, right? That is actually hilarious. We actually stumbled upon the thing that actually works. This is really like upvoted, but this one sounds complicated. Really, you should use equal equal to compare numbers when you care about numeric type, which should be most of the time. But we don't actually here. When you do care about when you don't really, okay, we don't really. Simplest thing that could possibly work. I don't know what this E is. E like a literal here? I don't know what the E is. That's interesting. I'm learning about syntax I don't actually know. Okay, so integer doesn't work. We already found that out. Okay, yeah. Check remainders with 0. That's really interesting. Okay, so 0.5 mod 1. So mod is, if you don't know, mod is just like an operator that's in every language pretty much that says, hey, if you divide by this, give me the remainder. Usually in most languages, it's only valid, I think, with integer math. I've never seen that actually. I've never used it with floating math. That's really dot zero. That doesn't work. Does this equal 0? Does it equal? Oh wait, no. This is not like a. I was about to say like I thought that like the 0 test wasn't actually going to work there. It's funny. I always forget that also that 0 question mark is actually built in. And it sounds like something that Active Record, or not Active Record, but active action support in Rails adds in. They add a lot of these niceties, and I guess they get adapted into Ruby eventually. Mod works and floats in Python as well. That's really interesting. I never knew that. Um, I guess that maybe that's something that's common in scripting languages. I really wonder if like a lot of these languages borrow from Perl and Bash, and that's kind of like where a lot of these ideas come from. So maybe it's there too. I don't know. I don't have a Perl installation right now though to check that. Super interesting. Okay, where was I with this? Interpret lengths probably have uh, probably most all have it. Yeah, I would agree with that. Most interpreted languages are roughly the same if you squint hard enough. Okay, so we figured out how to make sure this is an integer. So we need to turn this main into a generic thing that takes an arbitrary slope. Should be easy enough, right? We're actually just going to make a new main. And we can call this recount. I don't know why did I make this. What's going on with what's going on with my formatting here? This is like the type of casing that you do with JavaScript, not with Ruby. Ruby is always snake. Oh well, we're changing things, so should be easy enough. Words words said before disaster. Yes, always. Oh no, I'm not anticipating this getting too crazy though, right? Tree count. The only variable we're putting in here is going to be the slope. Let's actually just make this. We'll make this a named argument, just so it's easier to read down the line. And we're going to force that to be a float by convention here. Inverse slope. So we're multiplying our thing out. We're multiplying out our string because the string expands infinitely, just so we can get down this mountain. Does Ruby have type hints? I mean, I'm not sure what you mean by about that on like a language level. Ruby is completely dynamic, so it's really hard to build any editor or anything like that that can give auto completion or type hints and stuff like that. Those are just really difficult features to implement in Ruby. Just because you can add arbitrary methods at runtime, and they don't always necessarily follow. It doesn't always look like a normal, like it's not always like def whatever, because you can just add uh, make like macros and stuff that will dynamically add methods that have different function names and stuff like that. So it gets very tricky. When you're inside Ruby, though, like for instance in my terminal, you can sometimes do like tab completion for method names. I'm not sure if like this one does or not. Yeah, so this can do tab completion because uh, we know at runtime what the methods are on whatever variable we're looking at. So you can do some tricky stuff, but usually editors are not smart enough to incorporate all that. Okay, so we want to not print out the tree. We want to return it, and we're going to print this out from our main method now. So this should be functionally equivalent to what we had before. And still 173, so we are still in a good spot there. Okay, so let's actually, we can just kind of like bang out these guys right here. The 1, 2 is still the one that's tricky. So we can just bang out the first of these and see what sort of answers we get. This should just work. So we could put this into a loop or something like that and be a little more tricky, but we're just gonna do this iteratively because this is kind of like this is a coding challenge. It's a throwaway code. It doesn't really matter. So these should all, the things that we're looking for here is if our multiplier works properly, we should have high confidence that we're not gonna run over the index. Oh, we actually need to change char position here. So we have inverse slope. And for now, we're just going to cast it to integer. We're going to change that in a little bit because I don't think this guy here is going to be too happy about taking a float. But we're gonna do shenanigans in a little bit to handle our 1-2 slope. So that's not going to be an issue at that point. Okay, so this is what we have so far. A2, 173, we're still being consistent there. 84, 80. So that's the number of trees. Going back to the problem, we have an input file that looks like this, except it's much taller. It's still like 30 characters wide, but much taller. The hash symbols are trees that we run into, and the dots are open space. So we're just going through. We have a lousy toboggan, and so our toboggan can only go at exactly one slope. So for this round, our toboggan can only go down 1 over 1. For this round, it can only go down 1 over 3. And we're just counting the hash symbols that we come across as we go along. As we go along our merry way. Okay, so what now? What is next? I think we're finally at the point where we need to care about the floating, right? Because we're about to introduce, these are all inverse slopes, so 1 over 1, 3 over 1, 5 over 1, 7 over 1. We're about to do 1 over 2, which is scary and terrifying, but it's what has to be done. So I think the first thing we do is we make sure that this works okay with floats, right? So we take off the 2i, and we're going to say if char position mod 1 0, so if the modulus of this is 0.0 or 0 or whatever, if it's an integer, we will cast it as an integer, and we'll add it to our tree count. If we're at a fractional location, we're not going to bother. Now, this would break if we had like some other weird slopes, like maybe like right 2, down 3, or something like that. But because we know the problem and it's simple, this is not a generic solution. Don't get me wrong, this is not a generic solution at all. So there are certain cases where this will fail terribly. Sad. But for the 5 cases that we care about, this works perfectly. All right, so this should still run the same exact 82, 173, 84, 80. This should run the same exact thing. And we didn't have any exceptions, we didn't have any issues, we didn't have any problems. We're living our best life, and that is what we do here. So we're gonna add in we're gonna add in the case. 1 divided by 2. I guess we can just do 0.5, right? Because that will automatically be a float, right? Actually, for all of these, I'm being weird. Why am I casting explicitly to F? I can do this. I can do 3.0. I can do 5.0. I can do 7.0. It's a little more explicit to do like the 1 over blah blah blah, but I think the syntax is a little more difficult to read. And we'll do a little comment jobber so everything goes well. Let's run our program again. Let's see what happens. Okay, so we did not run into any issues, so this is a good thing. We didn't run into any overflows. So I think that all we have to do now is let's go back to our instructions. In the above example, the slopes are blah 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 blah. Trees respectively multiplied together, they produce the answer blah blah blah. Okay, so we are going to take all these. Multiplier. And we're just going to multiply this. We're just going to multiply. We're starting off with 1 because obviously if you multiply anything by 1, it stays the same, right? We're just going to do this for each of these. If I was being fancier, maybe I would do something where I'd put this into a list. Actually, do I just want to do that? Let's do that. I think that seems right. I can't help but try to get fancy. 1.0, 3.0, 5.0, 7.0, and then 0.5. We can do a map. I feel like there are inject shenanigans we can do here, but also I think that's the Cartesian product. Was there any like special syntax we did before for multiplying? Because I feel like we multiplied before, right? No, I don't think we multiplied. Nah, we just did straight multiplying. Yeah, that's fine. I'll do more work every time to try to do less work. That's my advice. I think that's the advice of every programmer. Let's call this result. And so what we're going to do is we're going to stick in inverse slope. Result times equals. So I feel like there's a cleaner way to do this with inject, but I hate inject. I totally get it, but I don't know. It just always seems very unreadable to me. So this is going to return the product. We're going to puts out that product. Oh, exit down there. Why do you do this to me? Why? We actually don't want to do that. Why did I say I wanted to do that? That's actually not what I wanted to do at all. We don't need to map. We're just doing each. I think if I wanted to do a mappy thing, that would be more of like an inject, actually. That's a big number. I hope that's accurate, but it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's like a that would be a pretty big number, right? Effectively multiplying by 10 by more. I'm like doing like a rough like low estimation, so 10 times 100, 1,000, 10,000, 100,000, 1 mil. So 1, 2, 3. Let's just stick this in. We may have shame here. We may have shame and be timed out, but this is a moment of truth. I think this is the number of trees that we have when we multiply together. I'm scared. I'm scared. I'm terrified. I'm petrified, but we're gonna hit this. And we get a gold star. That's how we do this. We feel great. Okay. Awesome, awesome, awesome. Okay, so that is the Advent of Code day 3 challenge. Actually, are we like still in day 3? What time is it? Return to my Advent calendar. So the next challenge is gonna be up in an hour. I'm not gonna be still running the stream in an hour, so we're gonna do that tomorrow evening, after I get out of work. So, but yeah, we're perfect so far. We have all the stars. This was actually fun. This was kind of like probably the most non-trivial one that we've had so far. The first one it wasn't hard, but it was the first one where I actually had to think a little bit. All these I could basically do on autopilot, and that was fine. It was fine to kind of like get your feet wet. I hope that they continue to ramp the difficulty, because it would be interesting if like I get to a point where like I'm a little bit stumped. That would be kind of fun, I think. I like getting stumped a little bit. So we are going to throw this all into the GitHub. So you can follow along at home if you want to reproduce these. I'll be including that in the description of the VOD that goes out. Yeah, we're day 3, right? Yeah, we're still day 3. Okay, let's push this out. Bam. So those are all up on GitHub. Feels great. Like a code to periodically. No, don't do anything for me. Don't do things for me. Just stop. No. What is this ASCII art that we're making here? I don't even know what this is. Is this normal? I've never done Advent of Code more than like a day or two, so I don't know what the heck this is, but I think we're making some sort of ASCII art, and that's pretty exciting. I'm in for it. Anyway, I think that we're done for today because we are out of Advent of Code. We're empty. They got nothing more for us. We're done. So we'll be back to do that tomorrow. If you enjoyed the content, feel free to hop on our Discord. There's an @ that goes out to everyone when I'm going live. Follow the Twitter. I update that approximately once every year, so that maybe don't do that. Do that if you want to, but don't feel obligated. Anyway, I think it's time for me to go. Time for me to go and do other things that are not streaming and not coding, because I've been coding all day and I'm done. I'm done. I'm Finet. We're gonna throw on some music and peace out. Thank you everyone for hanging out. It's been awesome.